I know we did a little bit of the inclined plane before we left for school, but I'm going to assume that everybody forgot everything. So let me briefly go over some of this. So we're going to assume this is what's given. We have an inclined plane with a weight, a 50-pound weight. That's what it says, actually, not 501, but 50 pounds. The actual effort is going to be how much effort you put in to push it up the slope. We're going to raise it 36 inches, and it's at an incline of 20 degrees. One thing to keep in mind is the definition for ideal mechanical advantage for an inclined plane is the slope length. In other words, how long this is, over the vertical height, which how high are we raising it up. So that's what it is, right? The slope length over vertical height equals S over H. Yeah, we kind of run out of letters and we use the same ones over and over again, but keep that in mind. All right, so first thing we need to do is figure out what is the length of the inclined plane's slope. In other words, what is S? And we're going to be using a little bit of trigonometry here, and given that we have something on the opposite side of that 20-degree angle, we're going to be able to use that. So if I go on this side of my paper, sine of theta is equal to opposite over hypotenuse, which in this case is going to be 36. Sine of 20 is 36 over whatever that is. And that's going to be our S, right? And if we move things around with a little bit of algebra, we'll say that S is equal to 36 over sine of 20 degrees. So hopefully you can figure that out on your calculator. Punch in what sine of 20 degrees is, which is equal to 36 over 0.342, giving us 105.3 inches. Okay, so that's what sine is. What S is, so that's the length of that slope. So, okay, we need to find out what is the ideal mechanical advantage now that we have S and we have H. So that's IMA is equal to S over H, which is going to be 105.3 over 36. Now that's inches and that's inches. The inches are going to cancel, giving us an IMA of 2.92 or thereabouts. Okay, so pretty straightforward, I hope. Now the next thing is, what is the actual mechanical advantage of the inclined plane? Well, actual, in this case, AMA is going to be defined as L over EA. L is this guy. What is the actual load, right? How much are we looking to lift? Well, we're looking to lift 50 pounds. But what is it going to feel like? Well, if you lift it straight up, it's going to feel like 50 pounds. But if you are pushing it up this inclined plane, it's going to feel a little bit lighter, right? So what is it going to feel like? Well, let's see. It's actually given that it's going to feel like it's 25 pounds. That's something that they didn't give us. I didn't give you earlier. So EA is going to be 25 pounds. So if you put 25 pounds in here, then the actual mechanical advantage of this thing is 2. So even though the ideal mechanical advantage is 2.92, which is more, AMA is always going to be less. AMA is always going to be less than IMA. Okay? So in this particular case, what is going to be our efficiency? Right? So efficiency, and for lack of, that's going to be kind of a goofy N, is going to be AMA over IMA, which is 2 divided by 2.92, which is equal to 0.68, or 68% efficient. So given that even though the ideal mechanical advantage is 2.92, the actual is going to be less because that's what it feels like. And we have a 68% efficiency, which is not bad, I guess, considering that you might be pushing it up a dirt slope. Okay?